Hey everyone, welcome back to Awesome AI channel. I am Sainath and today we are diving deep into AWS EKS to build something production ready. Not just simple hello world deployment, but a robust, scalable and multi-environment Kubernetes setup that could actually help you in your organization. Here's what we will accomplish in today's tutorial. We'll implement a multi-node EKS cluster from scratch, implement environment separation with namespace like dev, staging, and prod. We'll deploy three-tier application with persistent storage in each namespace. We will set up a MongoDB replica set for high availability. We'll set up monitoring and with Prometheus and Grafana. We'll implement proper load balancing with Ingress, and we'll doing this all with Helm charts. And I'll be sharing a production best practices throughout video. So before getting started, let's make sure that you have everything you need. So we'll be requiring a T2 micro instance, a EKS cluster with multi-node setup, and each node will be of T2 medium size. So yes, this project will incur cost from your AWS. So make sure you have enough money, and AWS is also providing $200 of credit for new users. So I have already made a video on that. So do check that out. A link will be provided in description. So I'll be giving a quick overview on this architecture. So we'll be having a Bastion host. This Bastion host EC2 instance will not be the part of our cluster. Rather, we'll use this instance to control our cluster, to launch our cluster, and set up everything. So through this cluster, we'll manage this our through this EC2 instance, we'll manage this our cluster. So the flow will go something like this. User will access the domain. This is our domain. This is the custom domain. If you have a actual real domain, you can use that also. As I don't have that actual domain, so I am creating this custom domain. And through this custom domain, the load balancer will route the traffic inside our cluster. And inside cluster, we have three different namespaces: dev, staging, and prod. And inside each namespace, we have this Kubernetes architecture running. Now let me give an explanation of this architecture. So request from load balancer will be routed to the ingress, and through ingress the request will be routed to the specific service, like slash will be routed to the front end service, and slash API will be routed to the backend service. And front end service will talk to the backend tier, and front end tier, and the slash API will be talking to the backend tier. And this front end tier is of a deployment resource, and we also have a deployment strategy as a rolling updates for zero downtime in both the front end and back end. And we have this service, headless service, so that no external user can access our service, database. Only backend can access our database. And then coming to database tier, we are using a resource as a stateful set, so that state of the um, MongoDB stays persisted even if the pod gets crashed or restarted or deleted. And we are using this AWS EBS to store our data. And this EBS will be created dynamically whenever the pod is created. So to configure this database, we're using this config maps and secrets, like username and password, and the configuration of database in this config map. So yeah, this is the architecture. And here we have monitoring setup in EKS cluster, that this Prometheus and Grafana. Prometheus will scrape the metrics from each node and store in time series database, and we have this Grafana to visualize the metrics. We'll set up a dashing dashboards so that we can visualize it. Don't worry, I'll help you to set up these all things. And yes, and I also created this awesome README where you should. I've given a complete guide how to set up step by step, so that you should not go here and there and search for how to set up and all. So you can check this README also, and I also created a blog for this project. So please do check that out also. If you are interested in leveling up your DevOps and Kubernetes skills, make sure to subscribe and hit that notification bell. And if you find value from this project, make sure to give thumbs up. That will really help for channel grow. So yeah, without getting late, let's get started. So come to our AWS console and head towards the EC2 and launch instance. Use Ubuntu as an operating system. Run T2 micro. Keep here. Allow SSH traffic and configure the storage. Give something like 25 GB of storage and just launch. So once your instance is ready, SSH inside your instance, go to connect, go to SSH client, take this, paste, so you will be able to connect. So once you are inside your instance, update your instance, which is a good practice for any Linux distribution. So do apt update. So this will update your instance. So now next step is, so we are done with step one, that is launching Bastion host. So the next step is to install AWS CLI and configure. And I assume that you know what is AWS CLI and what is configure. So let me give you a quick explanation of what is configure. So by this configure, you are connecting your Bastion host with your AWS account. So this is the command to install and configure that. So and also you will be needing a user. So go to IAM and create user and create access key and secret access key. So I will not be doing these two steps. I have already created these two steps. So I'll be starting directly from here. So copy this command, come to your terminal, paste that, hit enter. So this will install your AWS CLI. So once this is installed, use this command. So this will ask for your that access key and secret access key. So as I already created, so I have this access key and secret access key. Use region. So I'll be using EP South region for entire this project. So make sure you are in only one region. So you have configured your terminal with your AWS. So the next step is to install kubectl, eksctl, and Helm. So let me explain what is kubectl. So kubectl is a universal command for Kubernetes. By this command, by this tool, we will be accessing the resources of Kubernetes. And eksctl is a AWS specific command. By this command, we will be creating and managing our EKS cluster. And Helm is a package manager that will help us to deploy and manage the complex applications in Kubernetes, that will help us to package all our resources and deploy in just a single command. So now we'll install these one by one. So these are the commands to install them. kubectl, just copy this, come to a terminal, paste, hit enter. This will install kubectl. It will take some time, like a minute. Once installed, come to GitHub again, take this EKS command, paste, hit enter, and then Helm. Take this, hit enter. So all eksctl and kubectl, eksctl and Helm are installed. So next step, we will start by creating a EKS cluster. So the next step is to create the cluster. So here we are creating the cluster. So let me explain this command. We're using eksctl create cluster command, giving the name of the cluster, the region where we want our cluster, version, and we are creating this cluster without node groups, which means we're not adding any nodes to this cluster. We're just creating a cluster. Next, we'll associate and IAM OIDC provider. What is this OIDC? This is OpenID connector. Why we need this? Because in our cluster we will be allowing Kubernetes to access services of our AWS. By this, we can tell our Kubernetes resources can securely communicate with our AWS. Like we are using EBS volumes for a database, we can tell our pods to securely communicate with that AWS resources by this command. And next, we are creating this node group using again this command, which cluster we want to create, my cluster name and the region and the name of our node group. This name is the name of our node group. You can give any other name also, but for simplicity I've given the same name. And node type, we are using T2 medium, two nodes, minimum two nodes and maximum two nodes. And storage volume should be 25 GB. Each node will be have a 25 GB of a size, sorry, storage. And next we are giving sh key access. Make sure you have this EC2 key pair in your AWS. This is the name I have given you. Let's say you have any other name like my key. You have given your name as a my key. Make sure that you have that key in your AWS. Like when we are creating a Bastion host, we had this key pair inside our AWS. So make sure you have this key pair. And next we will after that we'll update this context. By this we are telling that in our EKS cluster we'll be having a multiple, like in our AWS we'll be having a multiple cluster. So by this command we are telling to talk to specific cluster, that is my cluster. So we'll start by creating this cluster. Copy this command, come to your terminal, paste that command, hit enter. So again this will take nearly 15 to 20 minutes to launch your cluster. So have patience for that. So I'll come you after once the cluster is launched. So now our cluster is ready. CKS cluster in AP South 1 region is ready. So next is to take this OIDC provider and paste. Hit enter. So it will create authentication with your account services. Next, to launch the node group. By this command, we will be creating two nodes in our cluster. Take this command, hit enter. Again, this will be taking some 5 minutes to launch two nodes. So next step is update your kubectl context. Take this command, go to your browser, paste that. So this will create that context. And next is to install AWS EBS CSI driver. So what is this AWS CSI driver and why we need this? EBS CSI driver is elastic block storage. By this, we are allowing our Kubernetes to dynamically provision and create and manage our EBS volumes. By default, Kubernetes don't have access to create those volumes. By this we are allowing giving that access. So take this command by Helm, we are adding that EBS. Take this, go to your console, paste, hit enter. See here your EBS repo is added. Next, to identify the node group IAM role. Uh, like you have two nodes in your cluster. By this command, we'll identify which role is you for given for your node group. By this command, you will get something output like this, and this will be your role name. This, just change this cluster name and node group name. Like our cluster name is my cluster, and node group also the same. So take this command, go to your terminal, hit enter, and change that name. Like here, the name is my cluster, and the cluster name also my cluster. So you got the output, and this is your role name. Take this, copy that, and next is to attach that IAM policy to the EBS CSI. Take this and change here that role name. Paste. So this was our role name here. Copy that, paste it here, paste it, hit enter. Now this role name is added to our node group. Next, take this command, come to a terminal and paste, hit enter. So this will launch your EBS CSI drivers for verification. Take this, come to a terminal and hit enter. See, these are the EBS volumes, EBS CSI managers that will be running in your cluster. Make sure that all these are running. Like here we had 00, now they are running. See, 3, 5, they will be running. See, so now let's start by deploying our application. Now you can deploy this without Helm and with Helm also. If you want to deploy it without Helm, go to just KTS folder and apply those all YAML files one by one. You will be able to deploy. But now I will be showing you how to deploy it with Helm. So scroll down with Helm. Go to 3 tier folder, like just come here and fork this, clone this uh, GitHub. Go to a terminal and git clone, just use that command, you'll be able to clone that. And once you are cloned, go to that folder, ls, go to Helm, cd Helm. Here are all the folders. Now to deploy it with Helm, just take this command, paste it, hit enter. Now by just this single command, all your resources are packaged inside release name called 3 tier dev, and those all are installed by just single command. You can in a namespace dev, you can check that by this command, kubectl get all in the namespace dev. You can see all your resources are running in this namespace. See, backend pod, frontend pod, and MongoDB. We are running two pods of stateful set, and name will be persisted like for Mongo 0 and Mongo 1. Even if the pod gets crashed or restarted, the same name will be given. to MongoPod. See running services, deployments, replica set, horizontal pods autoscaler. We are using a horizontal pod autoscaler for a high efficiency and fault tolerance. Those will be launched for HP will be given as there is a high traffic given to our pods. Now once you done, you can come here up. Now you need to access that. For that you need to access install this NGINX Ingress controller. For that just take this command, paste that. This will install all the Ingress controllers. Now to verify, take this command, paste, hit enter. See, a load balancer IP will be given. This is the external IP by which you can access your resources. But what we are told in Ingress that for a certain slash we will be accessing that. So take this command ns lookup and take this external IP, paste, hit enter. Wait for that because this external IP should be take this will take time to get live. So wait for some minutes. Then you try this command once again. You will get an IP for that. Then that IP we will map to our custom domain. And then we will access our application on IP on a domain myapp.local. I will show you that in next step. So now try this once again. See, you will be getting this address. Take any address of this. Let's say I took this, and then like I am a Windows user, slash ctc and slash host should be updated of your local system. So to update that, I will go to Notepad. Sorry, you should run this Notepad in administrative permission. So right click and run as administrator. Yes. So then once you are here, go to files, open all files, and then this host, open. Once you are here, change just this IP. Like I have already created this, you just give this IP and give a custom domain. You can give any name here. Like I have given myapp.local. Do that name, save, remove this, and come to your browser and search for myapp.local. See, you will be able to access your application. So now once you are here, come to your terminal. Just get all in the namespace. Just give this command. You will get this, and you see that your backend pod is getting crash of went into crash loop back of or it may be getting some errors. So to know that, just see the logs of this pod. So in the namespace dev, then you will see that something, your backend pod is not able to connect to the MongoDB. Why is this? Because you are running multiple pods of MongoDB, and this backend is not able to connect to this MongoDB pod. So for that, I have given steps in this README. Exec inside this Mongo 0 and give the replica set. That is, we need to allow this MongoDB to act as a replica set cluster. So that by giving Mongo 0 as a primary region, primary resource, means whenever a user comes and logs in, the data will be going to first to the Mongo 0 pod, Mongo 0 pod, that is this pod, and from that pod that data will be replicated to other pods like Mongo 0. Let's say you have any again Mongo 2, Mongo 3 pod, that data will be replicated to the all other pods. By you can do that by this command. So I will show you that how to do. Now just exec inside this Mongo 0, just take this command, come to a terminal, paste, hit enter. So you are inside your Mongo 0 pod. Once you are inside, take this command, paste, enter, hit enter. Now you're able to give the ID to your pods, like 0 to the Mongo and 1 to the second pod. And next is to check the status. See, primary. This is a Mongo and a primary pod. This is a replica set as a primary. And if you exec inside the second pod, that is Mongo 1, you will be able to secondary. And rest other like Mongo 3, Mongo 4, you will be seeing the secondary pod because data will be coming inside that pod after this pod. And next is to create an admin. Use admin. So you are inside the admin DB, and then just this create this DB. Why we are creating this? Because our we are adding this password and user and password inside this pod, so that backend can come with this backend with this username and password. Backend can authenticate with our MongoDB. Hit enter. Now the user is created. So just exit from this pod. Clear. The namespace dev. Now just delete this pod and run once again. You just delete that and check this once again. Your pod will be in a container creating state. Wait for some minute, it will be created. See, your backend pod is in running state. And next, you can access your application at this domain, and you can log in. Like, let's say you give any name, password, give any name. See, you are able to log in inside this application. So this is a my application. It can be your application also. Any services you have, like I have just using three tier: front end, back end, and DB. You can use any four, five, six services also. It's your choice. And that's it. And next step we will see how to set up a monitoring for this, and then I will show you how to do this with and same with staging and prod also. So in next step we will start with the monitoring. And now the next step is monitoring. Come to this readme. In this monitoring and with Prometheus and Grafana, firstly we will install this Prometheus community from Helm only. Take this command, come to your terminal, paste that, hit enter. So the Helm repo will be added. You can check that by Helm list. See, a EBS driver that we had installed previously, and this Prometheus community which we have installed now. And next is we'll create a namespace called monitoring. Paste that. A namespace is created, and then we'll install that all sorry, okay, this will install this Prometheus tag. What this will do is this will run a node exporter on each node, and what that node exporter will do is scrape the metrics from each node and store in time series database in Prometheus. And that we will use that data will be used by Grafana to visualize it in dashboards. So take this, just here, hit enter. So this will launch some pods. Wait for some minute. It will launch. Once this is run successfully, you verify that. Take that command, hit enter. See, you have uh, Grafana running, Kubectl running, and node exporters running. See, all those are running. And next is you just port forward that from this command. For simplicity, I am just port forwarding, but you can also access that by this domain only, that is by slash Prometheus also, but I have not done that now because you can do that by here only. See, in Ingress, what I've done for slash we are accessing front end service, for slash API we are accessing backend service. Similarly, you can do for slash Prometheus, uh, it should access this service. See this, you can do that also, but for now I am just put forwarding this. Take this command, paste it, and give -1 000 do and percent, it will be running in background. Hit enter, and now you can access that in port 9090. Now go to your console, just open the port 9090 from your Bastion host. Scroll down in security, inside this security group, edit inbound rules, add rule, view that 9090 custom anywhere IP, and one more add that is 8080. This will access by this port, that is Grafana. Next is save rule. Once you saved, come to instances, inside this is your public IP. Take this IP, paste that on 9090. You will be able to access your Prometheus. So this is your Prometheus, and similarly, first you need to put forward that Grafana. Come here, take the Grafana command. Take this command, paste -address 0.0.0.0.0 %. It will run in background. So at port 8080, take this port 8080, You will be accessing your Grafana. See, now this is the admin and password. You can take this password from operator. Come here, paste login. Now you're logged in. You can do that. This is your Grafana. Now you can set up your dashboards here. So see your connection, data source. See your Prometheus is already added. This is done by default. Now you can set up your dashboards from here. I will show you that in next step. So now let's set up the dashboards. Come to your Grafana dashboard, new dashboard, add visualization. Take a Prometheus as a data source. Now again, I'm taking the help of ChatGPT to take the like this uh, query to access the data source. So cluster usage. So this query will help us to know the what's the cluster usage for over a 5 minutes. CPU usage of a cluster. So go to your Grafana. Just you are in a builder state. Come to this code mode and then paste that command. Run query. See, you'll be able to see the CPU usage of your two nodes. That is nodes. You have two nodes in your cluster. You can change at what you want to see visualization. Here's a time series database. You can see it in graph also, gauge something. You can use any you want also. See, you can take pie chart also. And then if you want, if you feel this is okay, you can just save this dashboard. Give any description. And then just save that. Come to your dashboard. See, you'll be able to see that dashboard. Similarly, you can add as many as dashboards you want. Go to again visualization. Take queries again. Let's take something different now. Pod memory usage. Let's see how many pods have been restarted. Just copy this, paste that, run query. See, zero pods have been running. Let's see in just 15 minutes. It's zero. No pods have been restarted. Let's see another. Take this command, paste, run query. See, these are all the names of your pods in cube state matrix. See here, created name as backend pod, front end Mongo. These are all the names of your pod. All pods are running 111. So similarly, you can create as many as dashboards as you want and can set up. You can just save that dashboards via it. You can visualize it here. And this dashboards depends on organization to organization as you want which data to be shown. You can see and add that here. And now that is it. And let's say if you want to do the same for other namespaces, that is staging and prod, what you can do is go to this readme and take those commands from here. That is yeah, namespace for staging and namespace for prod. You can take these commands and paste that. It will be running for specific namespaces. And let's say if you want to change that values, go to this Helm. Let's say I want the values for stage environment. That is for front end pod, we want two replica sets. That will run two replica sets. Let's say if you are in prod namespace and you want front end should run three replicas, then you can change this value and you can run that also. The in a front in staging, you will be having two pods running of for front end, and in prod you will be having three replicas will be running of in a prod namespace. You can just change these values and it will be running completely in isolation mode for all three namespaces. Wow, look at what you have built together. You have set up a production ready EKS cluster with multi-node setup, three complete environments with proper isolations, persistent storage with dynamic provisioning, high availability MongoDB replica set, monitoring, load balancing, and ingress management with auto scaling capabilities. You have done a lot. And in next step, we will try to integrate it with the CI/CD, that is using GitHub Actions for CI and Argo CD for continuous deployment. So now as this is done, we'll destroy all those resources now. So this is the command. Don't worry, I'll provide this command in README. And then just hit enter. This will delete all the resources in dev namespace. And once it is deleted, now let's delete this EKS cluster. For that, go to this README, scroll down, and take this command to delete the EKS cluster. Copy this, come to your terminal, see, paste that, hit enter. So this will start deleting your cluster. Again, this will take nearly 10 to 15 minutes to delete your cluster. Once this is deleted, we will delete our Bastion host. And now if you once your cluster is deleted, delete your Bastion host. That is, go to your console instance, check this box instance state, and just terminate this. So this will be terminating your Bastion host. See, these are the nodes that our cluster had created. These are T2 medium nodes. And once your Bastion host is deleted, you are done. And yeah, if you found this tutorial helpful, please give a thumbs up and subscribe for more DevOps and cloud content. Drop a comment if you have questions or suggestions for future videos. The complete code and documentation will be provided in GitHub. Link will be in description. So do check that out. Thanks for watching. So I will see you next one. Thank you.